In this video, we're going to look at understanding ratios using a bar model, also called a tape diagram. And let's review what a ratio is. A ratio is a representation of the constant relationship that two numbers have in a given situation. So here we have an example of a ratio, and I have the tape diagram at the top of that. If you remember last video, we talked about using tape diagrams to understand ratios. So we have a 1-to-3 relationship, and if there were 2 reds, we know that there would be a total of 6 yellow. Okay, and if there are 3 reds in a 1-to-3 relationship, we know we have a total of 9 yellows. And this is helpful to us, but you can see how very quickly we would just be able to deal with single digit or maybe a little above numbers in a tape diagram, because otherwise we're going to run out of room very quickly. So a bar model or a tape diagram is a great way for us to understand and solve ratio problems when those numbers sometimes become a little bit bigger. So this is what a bar model looks like, and in this particular ratio for the bar model, I've chosen a ratio of 2 to 3, and I've got a ratio for every 2 cars out in the parking lot, there are 3 trucks, which gives us a total of 5 in each group. So out of every 5 vehicles, 2 of them will be cars and 3 of them will be trucks. Well, how are we going to use that to help us solve problems? We can see here's our ratio. This represents the top, which is the cars. So let's go ahead and label that. Okay, so these are the cars and these are the trucks. Okay, and so here we have our relationship of 2 to 2. Now, one of the important things we have to understand about ratios, and we need to know, is that every one of these boxes represents an equal group. If we go back to our tape diagram for just a moment, we can see that same concept displayed, because here we had 2 groups of 2, and here we had 2 groups of 3. So there was always the same number of groups. Here we have 7 groups of 2 and 7 groups of 3, giving us a ratio of 14 to 21, which is the same as 2 to 3. So in the bar model, every one of these boxes represents an equal amount because it represents the multiplier. Okay, so let's go to an instance where we have a 2 to 3 ratio. So for every 5 vehicles in the parking lot, 2 are cars, 3 are trucks. What if there were 10 cars in the parking lot? Okay, so what we have is we have 2 equal groups that represent the cars. And let's do orange for the trucks. So for every 2 groups of cars, we have 3 groups of trucks, and we know we have 10 cars. Well, what we can see here is that there are 2 equal groups that make up the 10 cars. And 5 times 2 is equal to 10. And again, one of the things we know is we know that all of these groups have to be the same, or it's not a ratio. So now we can quickly figure out if there are 10 cars, if we multiply 5 times 2 to get 10, we multiply 5 times 3 to get the number of trucks. And if we need to know the total number of vehicles in the parking lot, we can just add the number of cars and trucks to get 25 total. Or we can just say, well, there are 5 groups, total of 5 groups, and 5 in each group, and 5 times 5 is equal to 25. Let's look at another example. In this example, we're going to deal with a larger number. Okay, let's put 99 trucks out in the parking lot. Okay, still the same ratio. For every 2 cars, there are 3 trucks. So for every 5 vehicles, 2 cars, 3 trucks, and we know that 99 of them are trucks. Okay, well, We still have the same situation here, only this time instead of cars having two groups of cars, we have three groups of trucks that are equal to 99. 99 divided equally into three groups is 33. And I know because this is a ratio, every group is the same size. So that tells me quickly that there are 66 cars out in the parking lot. And if I add 66 to 99, I get 165. Or if I wanted to, I could multiply 33 times 5, and I would still get 165 total vehicles. Let's take a look at one last problem. And in this problem, what we're given is the total. So we don't have two groups of a certain number of cars. We don't have three groups of a certain number of trucks. All we know is that the total is 625. But we can still use our diagram to help us solve this because we know that there are a total of 5 equal groups. Okay? And notice that our tape diagram wouldn't be very helpful to us here because our tape diagram only went up to 12 groups, and if we were to use chips to try and solve something like this, we'd be spending a lot of time lining up our chips. So here's what we can do to solve this one. Let's take what we know, and what we know is there are 5 total groups, and those 5 total groups are each the same size, and they make up the total. So if we say take 625 and divide it by 5, and 25 gives us a 0 remainder, tells us that there are 125 cars in each one of the groups, or 125 vehicles in each group. 125. So 3 groups of 125 here, 3 groups of 125 here, 5 groups total. Those 5 groups equal the total number of vehicles. They are evenly distributed. So now I know that 2 groups of 125, there are 250 cars. 3 groups of 125, there are 375 trucks. And that's how you would solve problems using a bar model.